Welcome back, Nature and Code. We're in chapter 7, and we have just started implementing a spatial simulation of an epidemic. And we did this by initializing a grid with 10,000 individuals or 10,000 cells. Each cell is occupied by one individual. They are all susceptible except one. A random individual is infected. This is our patient 0. Now our goal in this video is to develop the method that will allow infection to occur. So let's go ahead and implement this method. So before we get started, let's think about how we will update the grid. We could, of course, again, just calculate, what's going on in each time step, then update the grid, calculate what's going on in the next time step, update the grid, and so on. If we did this, just like in chapter 5, this would be actually way too fast. The calculations will be too fast. And so we have to, again, resort to our neat little trick that we discovered in chapter 5 using the set interval function or method that is provided by JavaScript. So set interval allows you to execute some code at specific time intervals. And this is exactly what we're going to do here again. So we're going to use this method, set interval. And again, just as a reminder, its first parameter is the name of the function. So simulate and visualize, and we haven't defined this yet. We will do this. And the second parameter is the number of milliseconds at which this should occur. So for example, I say here 50, then that means every 50 milliseconds the function simulate and visualize will be executed. So let's go ahead and implement this function. So function simulate and visualize. So I'm just gonna copy this here, simulate and visualize. And what it does at each 50 milliseconds is it runs a time step. And again, this is a function that I will have to implement. And after it's run this time step, it will then update the grid. And for this, of course, we're going to use our update grid method. And the update grid method requires the same parameters as the draw grid. So first the data that should be visualized, and then optionally this array of states and colors. So I'm just going to copy this here and paste it here. All right. So now we have to run our time steps here, and we have to implement this function. So let's go ahead and do this right here. So function run time step. Okay, so what should happen each time step? Well, a couple of things should happen. So first of all, each individual that is exposed to an infected individual, each susceptible individual that's exposed to an infected individual should become infected with a probability beta, right? Recall that beta is our per contact, per time step probability of infection upon exposure. And then the second thing that should happen is each infected individual should recover with probability gamma per time step. So what I'm going to do here is I'm first going to implement the infection step. So this will be, somewhat an SI model. It's not technically an SI model, because in an SI model usually there's there's a recovery phase as well, but then the recovered individual will just be susceptible again rather than recovered. But at this point, I'm just going to implement the infection logic. And once you're infected, you will always stay infected. And then in the next step, we'll do the recovery. Okay, so infection, how should this work? Well, first we have to ask ourselves, okay, who is actually exposing whom? And we know that infected individuals expose susceptible individuals. But take this example of our patient 0 now. So there's this patient 0. Let's go switch over to the browser. Yeah, this guy here. So he lives here in this sea of 9,999 susceptible individuals. Now, are they all exposed to this individual? Probably not. So we have to come up with some rule, that defines, okay, who is actually exposed. And the way to do this is to think about contacts, right? The same is true in real life as well. If you, for example, have the flu, who can you expose? Can you expose everyone who lives in the same country as you? No, of course not. Only those people with whom you are in contact. And what exactly defines a contact depends on disease. If you think about something like the flu, you would have to be in close proximity to this person. If you think about something like the measles, that can stay, the virus can survive airborne in a room for up to 2 hours. Well, you don't even have to be in the same room at the same time, but still, the definition of a contact then is that at least people are in the same room, in a certain time interval. If you think about something like HIV/AIDS, obviously there has to be a sexual contact or a blood contact, and so on. Each disease has its unique way of, defining a contact. Now we're going to keep things simple here. We're going to keep, thinking about a flu-like disease. So close proximity will be required. And to make this simple, because we have this grid here of cells, we're just going to say that, the surrounding cells, the cells that are directly surrounded, those are the ones that will be exposed. So let me show you what I mean by that. So, we have our grid, and you remember the grid from chapter 5, of course. And you remember the situation, right, where you have individuals living on this grid and many, many grid cells. We're going to say now, here's an individual, and this individual is in contact with all of its neighbors. So this individual is in contact with this individual, 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 and with this individual, and with this. Vice versa, the individual over here is, in contact with all of these individuals. So this is quite similar to this mating distance that we had in chapter 5. So the only exception here will be that you cannot infect yourself anymore. That doesn't make sense because you are infected, and once you're infected, you cannot reinfect yourself. But you can infect susceptible individuals. So if there are any susceptible individuals in these surrounding cells here, then they will be exposed. So there could be a situation, for example, where, following our color code, where you have these individuals here being susceptible. But then, you might have two individuals that are also infected. So in this case, this individual will expose only these 1, 2, 3, 4, 5, 6 individuals. Vice versa, let's say we had a situation like this, perhaps. What would it mean for this individual here? Well, this individual would be exposed by this individual, but also by this, and by this, and by this, right? Because they're all neighbors of this individual here. So we have to take this into account. So basically what we have to do is we have to go through each individual, and then when an individual is infected, we have to say, all right, now you will expose all your, if an individual is infected, then we will say you will expose all your susceptible neighbors. So let's go ahead and implement this idea in code. All right, so now the first thing we have to do is we have to initialize our temp grid. So let's go ahead and do this. This is fairly straightforward. So for var I equals 0, I smaller than grid length, and I equals I plus 1. Okay, so remember we had our temp grid here that was initialized to an empty array, and this should be essentially a copy of the grid. So we're just going to go ahead and say temp grid I equals an empty array. So this will work the first time we do this, but it will also work in the second time step and third time step, because we're essentially just resetting the temp grid in the second time step and the third, and so on, by setting this value again to an empty array. And now, just like we did in the init grid, for var ii equals 0, ii smaller than grid length, and ii equals ii plus 1. So now we can essentially go through each cell. So each cell is at temp grid ii now. And we're going to say, well, whatever we have at grid ii, we're going to store that here into temp grid. So here we're setting up or resetting, depending on which time step we are in, the temp grid, and then we're basically copying over all of the individuals in the grid into temp grid. And just as a reminder, we're setting up this temp grid so that we can update, all the states of the individuals quasi-simultaneously. There's nothing really simultaneous in this type of programming. Everything happens sequentially. But in order to avoid any weird temporal, conflicts that shouldn't happen, we're just going to set up this temporary grid, sort of a temporary storage, where we're going to keep track of the individuals in the new generation, or whatever the states will be in the next generation. But we're not going to set these new states right into grid, because that might interfere with the dynamics. So we're going to set things here in temp grid instead, and then once we're done, we're going to move everything back over from temp grid to grid. If this concept sounds unfamiliar, go back to chapter 5, where we talk about this idea in greater detail. All right, good. So I have now initialized my temp grid. So what I would like to do now is I would like to go through each individual on the grid, and if the individual is infected, it should expose its neighbors. All right, so I need another loop. I'm just going to copy this one here. And then I need, of course, another inner loop. So I'm just going to copy this one here. Right, you're iterating through a two-dimensional array. This is how you do it. Okay. So now I'm going to say, well, okay, if this individual here at grid I is infected, then it should expose the neighbors. And this is a function that I will have to define. Expose neighbors. And I'm going to pass on the coordinates here of this infected individual. So I'm going to do this in an extra function. What this function does, it will expose the neighbors, and if an infection occurs in one of the neighbors due to this exposure, it will infect the neighbor. However, again, it will not infect the grid, the corresponding individual on the grid. It will instead do this on the temp grid. So what I have to do now, after I've done this, once I've gone through all the individuals and check their status and exposed neighbors, I now essentially have to copy the values back from temp grid. So I'm again going to go through all the individuals. So again, I'm going to set up this nested for loop. And now I'm simply going to say, I'm going to put back into grid at each cell whatever I had in temp grid. So this is the final step. Okay, so these 3 steps, fairly straightforward. The first one basically just resets the grid, or initializes the grid, and then moves, copies over all of the individuals, all of the states in the grid into the temp grid. Then we're going to go through each individual on the grid, check if they're infected. If so, we will expose the neighbors, and if an infection occurs, it will occur in the corresponding individual on the temp grid. This is a function that we still have to define. And then once everything is done here, we're simply moving everything back from temp grid into grid. All right, so in the next video, we'll implement this expose neighbors function. See you in the next video.